Good morning, everyone. Welcome to IIBS IAS Academy. Science and technology is an essential part for UPSC Civil Services examination, both in prelims as well as in mains. And for most of the aspirants, getting knowledge in science and technology is slightly a bit difficult. So that is the reason. So I am bringing you the analysis of science and technology concepts for civil services examinations in the much easier way. And we're going to discuss my book, Advancements in Science and Technology, published by GK Publishers. Let us start now. So these are the contents for UPSC Civil Services examinations, which I have authored. So the very first topic is evolution of life on our special planet Earth. And we go to the biomolecules, cell and its organelles. That means we're going to study about the life as well as engineering associated with the life. Both the plant biotechnology, gene therapy, and all associated biotechnology associated with the life. And then we go to the space technology, and then the defense technology, and the energy sector, and finally the ICT. So we're going to discuss each and every chapter in detail. So first thing is evolution of life on our special planet Earth. This is the first chapter. So let us see what is life. The life is nothing but anything which responds to the stimuli. We call it life, right? So when we start talking about the life, first thing we have to understand is how the universe has actually formed. So we have to go to the geography. So in the 11th class NCRT, you will understand clearly how the Earth, how the planetary systems, how the stars have actually formed, how the universe have actually formed. So we have this beautiful theory called the Big Bang theory. About 13.7 billion years ago, so everything used to be existing in singularity, and there was a big bang. So the universe started expanding, and all the mass that exists started accumulating together to form the conglomerates, and these conglomerates gradually started gaining mass. And when the mass has become supermassive, the molecules within those gigantic objects started to fuse together. The atoms that were actually present were the hydrogen, and the hydrogen molecules started fusing together. And when the mass is sustainable enough for the fusion reaction, those gigantic bodies have become stars, right? And as the mass grew bigger and bigger because of the gravity, so the fusion reaction continued for so long time, and that resulted in the formation of the stars. And once the stars have formed, so whatever within the vicinity of the star have been gathered by the gravity, and everything which stayed farther started forming the conglomerates over there, forming the planets as well as the satellites. So this is how the solar system have actually formed. So if you see the solar system, the very first four planets we call as the terrestrial planets, and the other four we call as gaseous planets. So why do we call these as terrestrial planets? They are terrestrial because it has taken, because the sunlight is abundantly available. So all the gases escaped from the particles, and that formed atmosphere, so making the planet solid. But as we go farther away from the sun, so we see those are the gaseous planets because the gases could not escape from the particles. That is how they form the gaseous planets. And the next important thing for us is the role of gravitational waves in the discovery of the formation of the universe, right? So obviously recently we have in 2016, the Rain Weiss, the Barry, as well as the Kip have been awarded the Nobel Prize in 2017, because they, for the first time, we were able to measure the gravitational waves using the Laser Interferometer Gravitational Wave Observatory, right? And we have observed that whatever the gravitational waves that we have observed have come long back, about 1.3 billion years ago. That means if we were able to harness the information present in those gravitational waves, so we will be able to understand how the universe existed previously, right? So This is the reason gravitational waves are extremely important, and understanding the gravitational waves will give insights how the universe have actually formed before and how the universe existed years back. And gravitational waves have this peculiar property that they can travel through the entire universe without getting any disruptions, without interfering. So that is the reason gravitational waves are extremely important, right? And the next concept which we have discussed in our book is how the solar system has actually formed, right? As you can see over here, right? So about 4.5 billion years ago, the solar system was formed from the interstellar cloud, which collapsed due to the shock wave from the exploding star called the supernova, right? So there was a nearby star which exploded. From that mass, right? All those particles have started coming together, forming the star, right? The collapsed interstellar cloud transformed into solar nebula, right? When the gravity pulled more material into the center, the pressure increased, resulting in the fusion of hydrogen atoms into the helium, releasing massive amount of energy, eventually creating our sun, right? And all the particles which actually present near to the sun form the planets, which cannot be assimilated into the star. And here we have a question about the Pluto. When I was studying, we had these 9 planets, and later the Pluto was removed as a star, as a planet, and finally has been downgraded to be the dwarf planet. So the very first question we have to ask is what is the definition of a planet? That is more important to understand. Then you can clearly understand why the Pluto is not a planet. So that is the reason I have given the classification of the planet by the International Astronomical Union. Just give me a second. Right? So what constitutes a planet? A planet is a celestial body which must orbit a star. That is a basic thing. Right? Any planet should orbit around a star, and it must be big enough for gravity to force it to the spherical shape and should clear its neighboring orbit. Right? That means it should not interfere with any other orbit, and it should be spherical in size. That means size has to be sufficient enough to form a spherical shape, right? And the next one, a dwarf planet. So what do you call as a dwarf planet? Is a body that has an orbit around the sun, but sufficient mass is not present for its gravity to overcome the force to attain a nearly spherical shape, and has not cleared the neighborhood orbit, and is not a satellite. That means it should not be a satellite, and the size has to be sufficient enough to form a spherical shape, and at the same time it should have its own orbit. These are the conditions for a planet. And for a dwarf planet, the size is not sufficient enough to form a spherical shape, and it is not able to have its own orbit. And all other objects shall be referred to as small solar system bodies. So these are the definitions that we have. So what is the definition? It should have an orbit, right? And it must be big enough for the gravity to force into the spherical shape, and it must be big enough such that its gravity clears away any other object of the similar size near to the orbit. That means any object that is actually coming into its path should not interfere with the planet, right? That is the only way the planet could actually sustain, right? So what is this Pluto? So initially it was identified as the 9th planet, but was very small than the Mercury and even smaller than some of the moons, right? So that's why it was downgraded, and it was regarded as the largest Kuiper belt objects, right? It's known as the largest Kuiper belt object. So that's why it was downgraded to be a dwarf planet rather than being a planet. And the next important question we have to ask is what made Earth so special? Why Earth is so special? So when you're talking about the planets in our solar system, so we said that the 4 planets are the terrestrial planets and the other 4 are the gaseous planets. And within those 4 terrestrial planets, the Earth is the only planet which could sustain life, and the gaseous planet could not even sustain life. So the atmospheric conditions are the worst, and the sunlight is not abundant enough for the life could actually sustain. So among these 4 planets, terrestrial planets, So what made Earth special? What made life feasible on the Earth? So for that, we have to understand about the Goldilocks region. That means this is the position which is distant from the sun that could actually sustain life. The exact position that could actually sustain life. That means the Goldilocks regions or the regions which are neither too close to the sun that the higher temperature could actually destroy the life, or neither too far away from the sun that it will be the entire ice age where the life could not sustain. So it is in the perfect region that could actually sustain life. So this is what we call as Goldilocks region, right? So the Earth is in the Goldilocks region, and it could support the liquid water, right? That means if it is too far away from the sun, the liquid water cannot exist because it will be in the form of ice, and if it is too near, the entire water will be in the vapors. So this is the position where the water could actually exist in the liquid form, right? And at the same time, there are other factors that actually led to the creation of the life: the presence of atmosphere. So when you're talking about the presence of atmosphere, the size of the planet should be sufficient enough that it could actually hold on to its atmosphere. So for an example, so what is the hottest planet in our solar system? Not Mercury, but the Venus. Why the Venus is the hottest planet even though Mercury is closer to the sun? Because the sun's gravity has pulled the entire atmosphere, and the size of the Mercury is not sufficient enough to hold its atmosphere onto its surface, right? The gravity is not high enough. So that is the reason the atmosphere does not exist, but the Earth, the atmosphere exists because of the mass of the Earth. So that is the other reason. And the next one is the inclined axis, right? So the inclined axis which we have is one other reason where we have the seasons because of the inclined axis. We do not have the same season round the clock. The seasonal changes are occurring because of the inclined axis. So we have the equatorial belt shifting towards the north and the south, creating the monsoons, right? So we are having equatorial region, tropical region, and the temperate regions because of the inclined axis, and the frigid region at the poles, right? And the next one is the magnetosphere, right? The Earth has a magnetic field. So the Earth is a giant magnet. We have the North Pole as well as the South Pole, and this magnetosphere is actually interfering with the harmful solar winds and protecting the life on the Earth. And finally, the ozone layer. The harmful ultraviolet radiations are being protected by the ozone layer, and because of which the life would actually sustain. If the ozone layer was not actually present over here, so what could actually happen? So the gradual mutations and the life could not actually prosper, right? So these are the reasons what made Earth so special that life could actually sustain in the Earth. And the fundamental question, what is life, right? Since we started existing, since we started thinking, we have been asking the same question, what is life, right? So when you're talking about life, right, so the very first thing, first criteria is the life should work. That means there has to be some metabolic process. So we are taking food and we are having multiple metabolical processes happening in our body. So the respiration is a metabolical process, digestion is a metabolical process, the cleaning of the blood by the kidneys is a metabolical process, the enzymes working is a metabolical process. So everything is a metabolical process. Hormones being released is a metabolical process. So some work should happen within the body, right? So that is the first criteria. And the next one is grows and develops. Anything which has life should grow and develop. So that is the next important thing. It is not just replicating and growing in size, but they should be able to rebuild as well as repair themselves. So whenever something harmful is happening to the body could repair itself, right? So that is the growth and development. So that is the second important criteria to call something has life. And the third important thing is reproduction, right? So the species or any kind of a life form has to multiply itself, has to reproduce, has to pass on the genetical material to the next generations. So that is the third criteria. And the next one is responding to the stimuli. So any kind of an external stimuli that actually comes, the life form should actually respond to that stimuli, right? And adaptation. The last but not the least is adapt, right? The life should adapt to the changing circumstances of the earth. So there are multiple disastrous events that have actually happened on the earth. There are different global mass extinction events that have actually happened. So with every mass extinction event, the climate has become non-conducive for certain life forms to exist, and the life forms which could actually resist or adapted to the changing circumstances have survived. So the adaptation to the changing conditions is the next important criteria. So all these have constituted together to form life. And the next, okay, life has actually come, right? So how the species actually evolves, right? What are the reasons for the evolution of the life? Because when we see the species are much more diverse and everything is adapting to the different environmental conditions, and that is generating as a new species. We call it speciation. So and how this evolution actually happens gradually, right? As you can see, the Darwin has actually given the theories of the natural selection as well as the Lamarckian theory of evolution. So when the theory of natural selection actually comes, right? So any kind of a change, when it is desirable to the nature, will actually progress towards the further generations, and any kind of a change that is not desirable will actually be stopped. That is the theory of natural selection, or the survival of the fittest, we call it. That means the fittest organism will actually propagate to the future generations, or the genetical material which is bringing the change that is necessary for the necessary in the environment to sustain will actually progress to the next generations. So that is what we are talking as natural selection or the survival of the fittest. And here the Darwin could not actually tell what actually brought the change, how the change is actually coming. So the later, with the later Darwinian theories, we have understood that the changes are actually occurring through the mutations, right? Through the random mutations. Mutations are nothing but the changes in the genetical structure of the life form. So whenever the changes are occurring in the life form, if that change is desirable to the nature, then it will be propagated to the next generation. If the change is not accepted by the nature, then it will be stopped, right? Those are mutations. So we can say the mutations are followed by natural selections and then strengthened by the gene flow. That means how the genes are propagating to the larger population size and how the genetic drift is actually happening, right? So whenever the species actually moves to the new geographical area, that will adapt to those new circumstances, and finally that will actually create new species. That is how the evolution happens. So this is the first chapter that we have. So the evolution of life on the special planet Earth, right? So we have discussed about how the universe have actually formed, the Big Bang theory, and how the solar system have actually formed, and what constitutes a planet, and what is the definition of a planet, and what made Earth special, and what is life, and how the what are the driving forces of evolution. And once we understood these fundamentals, then we could actually go to the biomolecules. These are the basic molecules that have actually combined together to form the life itself. Once we understand the biomolecules, the raw materials that created the life, then we can actually manipulate them into however we want. So that is what the engineering we talk about, the basic genetic engineering, right? Once we understand these basics, we go to the advanced concepts of engineering. Okay. So if you're having any queries, please put down in the comments below. I'll be explaining in the next class, and you can actually try the MCQs given after the material as well, after the book as well. Thanks a lot. See you tomorrow. Bye.